Okay, we are going to go ahead and start Chapter 2, Section 5, using statistics and scatter plots. This is a pretty entertaining chapter, I think, so we'll see how it goes. Uh, First thing is the idea of bivariate information or bivariant data. It relates two separate pieces of data. So you could say eye color and height. You know, we could say eye color on the X and height on the Y. And the point of scatter plots and bivariant data is to see if there's a relationship between two pieces of data. Is there a pattern that we can identify? Um, does one set of data depend on the other? X represents your independent variable that lies on the horizontal axis, and then Y represents your dependent variable um, and lies on the y-axis. If you look at the drawings here, you will notice we have what we call weak correlation. So the idea with a scatter plot is that there are points on the graph, and then we try to draw a line through them that kind of matches or hits most of them, or that most of the points are crowded around. So if you look at this graph, most of the points, it's kind of spread out. Although there is a line of best fit, most of the points are not around that line, so we call that a weak correlation. A stronger correlation, um, most of the points are around the line of best fit. Okay, so you kind of see how most of these are kind of pretty close to the line of best fit. Not all of them, but most of them. Okay, and so just another example of a weak correlation here. And then here's an example of a stronger correlation where it's closer to the line. Most of the points are closest to the line. The other thing we want to talk about here is the idea of positive correlation and negative correlation and then no correlation. So no correlation, where it's difficult to find any line that would hit most of the points. There's no pattern, identifiable pattern that you can see. So we call that no correlation. With a positive correlation, we're looking at the data as we read it from left to right. And as you can see here, with a positive correlation, the graph as you read it from left to right seems to be moving up. So the idea with a positive correlation is that the independent variable and the dependent variable are both increasing. So if the x increased, then the y is going to increase. All right, so that's what a positive correlation is. If we look at a negative correlation is where, as you read the graph from left to right, the line seems to be going down. Oh, sorry. I stood there just started drawing dots. All right. So for this one, notice how my line seems to be going downward. All right. So with a negative correlation, one variable increases while the other variable decreases. The line moves downward from left to right. All right. So those are the three different types of correlations. A positive correlation, remember, both are increasing. All right, so we use scatter plots when we're collecting data. So you will be doing an activity soon where you'll be collecting data and you'll have your X and your Y. And of course, that depends on whatever you wanted to identify as your independent variable versus your dependent variable. In this example, we're just given a set of data. We have the scatter plot and we have our line of best fit already drawn. So based on this data, we're going to come up with an equation for the line of best fit. The equation for the line of best fit is important because we can use that to make predictions about other variables. For instance, in our table, x only goes up to 10. We can make a prediction about what would happen if x was 20, if x was 100, or if x was 50. So that's the whole point of writing the equation of the line. So the first step is to identify 2 points on the line. So I'm going to go with my first point here, which is about 2, 3. So we'll say 2, 3. And then I'll pick another point on my line. We'll say it's like 4, 7. Okay, so then using those 2 points, just like we've been doing, we're going to first calculate the slope. So m equals y2 minus y1 over x2 minus x1. All right, x1, y1, x2, y2. So I end up with m equals 7 minus 3 over 4 minus 2. So I get 4 over 2, which equals 2. So my slope is 2. Now you're going to take your slope and we're going to use the equation y equals mx plus b. I'm going to plug it in. Plug in our slope, and then we're going to choose one of our points to also plug in. So I'm just going to go with 2, 3. So my y in that case is 3. My slope is 2. My x is 2. And b I have to find. So 2 times 2 equals 4. So I'm left with 3 equals 4 plus b. Subtract 4, subtract 4. And I'm left with b equals -1. So if my b is -1, the equation of my line is y equals, slope was 2, 2x, and my b is -1. There's my equation. So if I want to find out what happens to y when x is, say, 15, then I just plug in 15 into the equation, and I get y equals 2 times 15 minus 1. 2 times 15 is 30. Minus 1 is 29. So in my table, I would get x is 15. When x is 15, y is 29. That's the whole point. Let's try another one. So in this case, I have my 2 points already identified on my line of best fit. I have 610 and 1620. Again, my first step is to find the slope. So the slope of this line, m equals y2 minus y1 over x2 minus x1. Notice how I keep doing that over and over again so I don't forget the formula. Again, go and label your points, x1, y1, x2, y2. And then I'm left with 20 minus 10 over 16 minus 6. So m equals 20 minus 10 is 10. 16 minus 6 is 10. 10 over 10 equals 1. So my slope is 1. Then choose either point. I'm going to go ahead and choose 610 and plug that into y equals mx plus b. So in that case, my y is going to be 10. My m is 1. My x is 6 plus b. So 10 equals 6 plus b. Minus 6 minus 6. I get b equals 4. So the equation of my line is going to be y equals, my m was 1, so I'm just going to put x plus my y-intercept is 4. So that's the equation of my line. All right. So now if I want to find out what would x be, I'm sorry, what would y be when x is 50, you're going to plug in this 50 in for x. And when we do that, we end up with y equals 50 plus 4. So y equals 54. Okay? So for this one, you can go ahead and try it yourself. Remember, you just need 2 points on the line. So for the first one, I'm going to do a little estimation here. It's about 734. And then for my second point, I'm going to choose this point here. It's 215. Same process, find my slope. Oops. M equals y2 minus y1 over x2 minus x1. So x1, y1, x2, y2. So I get 34 minus 15 over 7 minus 2. I end up with 19 over 5. Plug it in, then choose your 2 points. I'm going to go ahead with the first two down here with 2 and 15. Y equals mx plus b. My y is going to be 15. My m is 19 over 5 plus b. Subtract 19 over 5 from both sides. Those cancel out. Over here, I'm going to do the subtraction for 15 minus 19 over 5. So 15 minus 19 over 5. I'm going to put my 15 over 1. Find my common denominator, which in this case would be 5. So I'm going to times 5 here, times 5 here. I end up with 75 over 15 minus 19 over 5. That's that right? 75 over 5 minus 19 over 5. And then 75 minus 19 is going to give me 56 over 5. So my B is 56 over 5. And then write the equation of your line. Y equals 19 over 5x plus 56 over 5. Okay? And that concludes our lesson on using scatter plots.